All right, this is 4.6, corresponding parts of congruent triangles. So let's define that first. So by definition of congruent triangles, it states that if two triangles are congruent, then, let me get my pen, then the corresponding parts of congruent triangles are congruent. Okay, so meaning every corresponding part. And so we kind of defined that a while back when we talked about congruent polygons. Okay, and so even so with congruent triangles, same thing. Okay, and so this is what this whole unit is about, is congruent and all types of parts of triangles. And so the main focus on this part right here is to always remember that corresponding parts of congruent triangles are congruent. Okay, so I'm going to underline some key letters here so that way you're going to use this as an acronym. So C, P, C, T, C. Okay, so we're going to use these letters C, P, C, T, C to refer to this definition. Okay, and it stands for corresponding parts of congruent triangles are congruent. Okay, so we're going to use that in our proofs today. So it says, is AD congruent to BC? So the first thing you want to do is maybe go put a little question mark on there. Here's AD and here's BC. Well, it's not marked, so obviously we have to show a proof. So if I can prove these two triangles congruent, well, then I can use that definition I just wrote down, because these two look like they would be corresponding, okay? And so if these are congruent, then that'll allow me to say that, well, since the triangles are congruent, that means every part that is corresponding is going to be congruent to each other. So that's my first thing that I want to do, is prove the triangles congruent. So like you did in the last section, would you say these two triangles are congruent? And the answer is yes, because we have this angle congruent to this angle. We have this angle congruent to this one. It's not marked, but it has angle 1 and 2, and those are vertical angles. And so you know that those two are congruent. And then it has the included side right there that is congruent to this included side. Okay, so look at the pattern here. It goes like that. This angle is congruent to this angle, this side's congruent to this side, and this angle is congruent to that angle. That pattern, angle, side, angle. So that's how I want to list that out. And sometimes it's good to write down the order that you want. So you want to write down the angles first, the side second, and the angles third. And then we write the triangles, just like we talked about in section 4.4.4.5. Okay, so let's list, it doesn't matter which angles you list first. So I'm going to list my angle A congruent to my angle B. Okay, and that is given because they marked it for us. Okay, now I'm going to go with the side. Side AM is congruent to MB. That is also given because they marked it for us. Angle 1 is congruent to angle 2. And that is the definition of vertical angles. Okay, if you write vertical angles, that'll be fine. Okay, now how are the triangles congruent? You want to make sure you write them in order, in corresponding order. So triangle, let's just go AMD, is congruent to triangle BMC. Okay, and why? Because of the angle side angle conjecture that we again did this last section. So now that I've listed the two triangles congruent, you want to always make sure, are they corresponding? AD to BC. Look at that pattern. I'm going to use my red pen. AD BC. See how they're listed in the triangle as well and on the picture? So then the answer is technically yes, they are congruent. So we're going to write AD is congruent to BC by the definition of CPCTC. Okay, because I proved the triangle is congruent, therefore I'm allowed to say that statement because they are corresponding. Okay, so is AD congruent to BC? The answer is yes, and we have a proof there to show that. All right, let's go to the next one. Let's try this one. It says, is AE congruent to BD? AE congruent to BD. Okay, so when you start seeing overlapping triangles, just like I said in the last section, I would really prefer that you redraw them, so that way it's easier to see. Okay, so I'm going to draw this triangle over here, and then the other one over here on this side, just so I can see them separately. So like this is A, D, and B. This one is A, E, and B. Okay, let's mark what they already have in the picture. So that angle is congruent to that angle. This tiny angle is congruent to this tiny angle. And one thing that's not marked, but you should know, is that AB is congruent to AB because it's its own segment. It's a shared segment, which is that reflexive property. Okay, so now the question was AE congruent to BD? So I'm going to put that question mark like I did on the last one. Here's BD. Here's that. Well, first of all, are the two triangles congruent? I see a pattern here. Angle, angle, side. Angle, angle, side. So yes, these are congruent. So I'm going to write that down off to the side. Angle, angle, side. Then I'm going to list the triangles. And then I should be able to prove those because those look like they are definitely in corresponding parts. Okay. So the first thing first is I'm going to list the angle. I'm going to do angle. And I have to use 3 letters because we have multiple letters represented in each triangle. So I'm going to say angle ADB is congruent to angle BEA. And that is given to us. Okay, so that one is the one up here, this angle up here. Okay, that angle is congruent to that angle. Now I'm going to do this one down here at the bottom. So I'm going to say angle EAB is congruent to angle DBA. That is also given to us. Now I'm going to list the side. I'm going to say AB is congruent to AB, and that is the reflexive property. If you forget the word reflexive, you can write shared side, okay, or the same side. All right, therefore I'm allowed to write the triangles congruent, so I'm going to say triangle ABD is congruent to triangle, and make sure you write them in corresponding order. ABD, that's going to be BAE. Okay, and how are they congruent? By angle, angle, side. Okay, you could also write side angle, angle. That's the same thing. It's just the reverse order. And so yes, now AE I can say is congruent to BD by CPCTC, because all corresponding parts are congruent if the triangles are congruent. Okay. All right, there's that proof. So the answer is yes. Okay, and I have a proof to explain. All right, last one. In the figure, AC is congruent, angle A is congruent to angle C. So let's go mark that. Angle A is congruent to angle C. They gave us that. And then it says angle ABD is congruent to angle CBD. So use different tick marks or multiple arcs. And then it says, is AB congruent to CD? So remember, you always want to go mark those little question marks. AB, is that side congruent to CD? That already looks non-corresponding, okay? This side is congruent to itself. So these two triangles technically are congruent. However, would you say this side is congruent to that side? Okay, well, let's write the triangles that are congruent, okay? You don't even need to write a whole proof out, but look, triangle ABD is congruent to triangle CBD. And they're asking us if, which is these two letters in the front, is congruent to CD, which is those two right there. So clearly, even when we write out the congruent statement, they're not congruent, okay? Now they are congruent by angle, side, but the answer is still going to be no to this question because they are not corresponding. So you can say no, they're not corresponding. So even though we have congruent triangles, you don't want to waste time writing out a proof because, I mean, it's not going to help us explain why this would be congruent to this, because in fact they're not, because they're not in corresponding parts or corresponding positions. Okay, so you don't write out a proof. Okay, you don't really need to do anything here. I just wrote that out so we can see how they're not in the same spot, and that is it. Okay, so those are 3 examples on how to use the term or the definition CPCTC. Corresponding parts of congruent triangles are congruent. That's it.